Hello everyone, I've got a couple of data sets here and I'm in GeoGebra. So if you want a copy of GeoGebra Classic 5, which is what I've got here, what you want to do is go into the Google Classroom stream and I've got a link in there that will give you access to this really cool piece of software. So look at what we've got. We've got a couple of data sets here. Now, I would just want to focus in on data set A for the time being. Let's imagine that these are the ages of people in a maths class. So in this maths class here, there's a 17-year-old, a 19-year-old, a 21-year-old, a 17-year-old. Here's a much older individual, maybe coming back to get their numeracy or whatever for some reason. 65-year-old, there's a 52-year-old, all the way down here to a 40-year-old. Okay, that's class A. So if we want to just analyze that data set, what we can do is we can select on the column that we want up here. And by the way, if you want to find the spreadsheet in GeoGebra, you just want to go into the view. There's lots of cool different views. The one that we want though is spreadsheet. Okay, so we've clicked this column here and we're going to click on this button, which is called one variable analysis. And that will allow us to analyze these data right here that we've got. So just to confirm that, yep, we want to analyze column A, the one that starts with 17 and ends with 40. Let's analyze. And you can see we've got this little thing over here. So I'll drag this across so I can see it a bit better. Okay, right now we're looking at a histogram. A histogram is kind of like a bar chart or a column chart where everything's stuck next to the other guys. So there's no gaps here between the columns. It's not really what we want right now. I first of all want to have a look at a stem and leaf plot. So this is saying, look, it seems that in this class, perhaps unsurprisingly, things are more clumped down towards the lower end of the age spectrum. So there's a 17-year-old, a 17-year-old, 18, 18, 18, 19-year-old. That takes care of all the teenagers in the class. Now let's look at the 20-year-olds. There's a 20-year-old, a 20-year-old, a 21-year-old, a 22-year-old, a 22-year-old, and two 24-year-olds here. And right at the top end of things, there's a 65-year-old. This is useful if you want to just see the general shape of the data set. You could say, well, it's skewed down towards the lower end of the age spectrum. It's also useful if we want to work out, well, what's the mode of the data set? So what's the most common age? What is it, guys? Yep, it's 18 because there's three 18-year-olds in this data set here. Or you can say, nope, I would like to have a look at a box plot. Remember what a box plot's telling us? It's telling us the minimum age, the maximum age, and the interquartile range. So this is Q1, Q3, and this line in the middle of the box is called the median. That's the age under which half of the people are and over which half of the people are. So it's 20 odd or something like that. You can see here we've got this outlier, this crazy guy, 65 years old, who's studying with all the younger guys. If we want to switch off outliers, we can do that easy enough. We'll come up here and we're going to click off there. And we'll say, no, I would like the whisker to go really up to the oldest person, up to the 65-year-old. Okay, so there's quite a wide range of ages in this class. It goes from 17, I think it was, all the way to 65. Whereas the interquartile range is a little bit more compressed here. Okay, this button here is really useful. This is called the Show Statistics button, and we're going to click on it, and it's going to say, look, there are 20 people in your data set. The mean age is 27.65. I guess we could round that to about 28. The minimum age is 17. The maximum age is 65. The median age is 22. Remember what that means? Half of the people in that class are under 22 years old. Half of the people in that class are over 22 years old. And Q1 and Q3, these are the quartiles, the first quartile and the third quartile. They're saying for Q1, because it's 18.5, they're saying that a quarter of people in that class are actually under 18.5 years old. And because Q3 is 34, a quarter of people in that class are over 34 years old. So when we calculate the interquartile range, it's going to be Q3 minus Q1. Let's quickly do that. Let's work out what the interquartile range is. So Q3 minus Q1 is going to be 34, subtract 18.5. So the interquartile range is 15.5 years in this class, whereas the actual range of ages is 65 minus 17, maximum minus minimum. So there's a range of ages of 48 years in this class. It's quite spread out, this class. Okay. Now, I'm just going to nuke that for the time being. And I want you to think about class B. Is this more spread out or less spread out than class A, do you think? Yeah, if you said it was less spread out, you would be dead right. So let's just confirm that by doing one variable analysis on this data set. And you can see, look, the minimum age was 16 and the maximum age was 21, was it? So now the range of ages is only 21 minus 16, which is only 5 years. The interquartile range is even less spread out. In fact, I can't even see the median on this box here. So what we might want to do is just have a look at the statistics here. Remember the button, okay? It's saying, look, Q1 and the median are actually the same value in this data set because it's so clumped together. It's not spread out at all. So the max minus the min, that's the range. The interquartile range is Q3 minus Q1. Let's do that just quickly. I guess we don't need a calculator for this, but let's do it. So Q3 is 18.5. We'll take off Q1 and we get an answer of 1.5. The interquartile range for this data set is only 1.5 years. Whereas for the other data set, what was it, 15 or something? That's telling us it's not very spread out at all, this data set. Okay. Now, here's something to think about. Imagine for a moment that this guy was actually 120 years old, which is a bit silly, isn't it? And let's say that this youngster down here was only 3 years old. Gee, that would be a struggle to teach that class. But anyway, let's just move on. What do we want to say now? Do we want to say that class B is the more spread out class in terms of the ages? What do you think about that? I guess there's a couple of ways of thinking about it. On the one hand, you could say, yeah, it's more spread out in the sense that the range of ages is much greater. Now the range of ages, the max minus the min, 120 minus 3, is 117 years. So there's a wide variety of ages there, okay? Much higher than in class A. At the same time though, I get the feeling that even though the raw sort of range of ages is much greater in class B, in some sense, it's still not a very spread out data set. Do you see what I'm getting at there, guys? It's kind of, the ages in general are all pretty similar to each other. It's just that we've got a few outliers here. So let's have a look at that. Let's analyze this data set now. And, one variable analysis. And yeah, it is true that the range of ages is massive. It's from 3 years old to 120 years old. But look at the interquartile range. It's really, really compressed here. This box is not very wide at all. So in fact, look, the interquartile range, Q3 minus Q1, is only 2 years. Even though we've got a hugely diverse set of ages in raw terms, when we look at the interquartile range, it's still not very spread out. It's going to be 19 minus 17, and that's 2. Okay, so this is the advantage of the interquartile range as opposed to the actual range. The interquartile range isn't very sensitive to outlying values. So if you've got crazy values in your data set and you want to work out how spread out is your data set, the interquartile range gives the best picture because it's not very sensitive to outliers. Hopefully that makes sense there. By the way, these 5 numbers here are called the 5-number summary. The 5-number summary of any data set is the minimum value, Q1, the median value, Q3, and the maximum value, like that. Those 5 numbers are called the 5-number summary, and they can be really useful. the bigger the data set gets. So you can imagine if you had 25 million people in Australia and we measured all their heights, it'd be really hard to get your head around all of those numbers. But if you know the 5-number summary, if you know the minimum height, the maximum height, the median height, Q1 and Q3, you get a good picture of what that data set's like, even though you're only looking at 5 numbers, not 25 million numbers. Okay, one last little trick that we've got here in GeoGebra, and this is really cool. Let's compare these two data sets. So what I'm doing here is instead of just selecting one column, I'm going to select the first column, hold down Shift, and select the next column together with it. Okay, and we're going to now, instead of clicking on one variable analysis, we'll click on this little arrow here, and we'll do multiple variable analysis. And we'll say, yep, these are the columns that we want to analyze. Thank you very much. And now we've got what are called stacked box plots. So the first class is right here. You can see that its raw range of values is, although it's quite wide, it's less than in class B. But although class B has a really huge range of ages, as we saw before, the interquartile range is quite small still. And that's capturing the idea that, yeah, it's not a very spread out data set actually. Most of these ages are quite similar to each other. So that's the advantage of doing stacked box plots. You can easily see, hey, this data set's really spread out, this one's not, because the box is very, very small here, and the box is relatively big here. And down here, look what we've got. We've got the 5-number summary for both data sets. For class A, the min Q1, the median Q3, and the max are here. And for class B, the min Q1, the median Q3, and the max are down here. Hopefully that helped, guys.